Good morning. Welcome to day 15 of Advent of Code. Beacon exclusion zone. You feel the ground rumble again as the distress signal leads you to a large network of subterranean tunnels. You don't have time to search them all, but you don't need to. Your pack contains a set of deployable sensors that you imagine were originally built to locate lost elves. These sensors aren't very powerful, but that's okay. Your handheld device indicates that you're close enough to the source of the distress signals to use them. You pull the emergency sensor system out of your pack, hit the big button on top at the sensor zoom, and the sensor zoom off down the tunnels. Once a sensor finds a spot it thinks it will receive it a good reading, it attaches itself to a hard surface and begins monitoring for the nearest signal source beacon. Sensors and beacons always exist at integer coordinates. Each sensor knows its own position and can determine the position of a beacon precisely. However, sensors can only lock onto the one beacon closest to the sensor, as measured by the Manhattan distance. There is never a tie where two beacons are the same distance to a sensor. It doesn't take long for the sensor to report back their position and closest beacon, your puzzle input. For example, sensor at position X and Y, closest beacon, and so on. So consider the sensor at position 218, the closest beacon to it is at minus 215. For the sensor 916, the closest beacon to it is 1016. Drawing sensors as S and beacons as B, the above arrangement of sensors and beacons looks like this. This isn't necessarily a comprehensive map of all beacons in the area, though, because each sensor only identifies its closest beacon. If a sensor detects a beacon, you know there are no other beacons that close or closer to that sensor. There could still be a beacon at the that just happened to not be the closest beacon to any sensor. Okay. This sensor closest beacon to 10, and so you know there are no beacons that are closer to in any position. None of the detected beacons seem to be producing the distress signal, so you'll need to work out where the distress beacon is by working out where it isn't. For now, keep things simple by counting the positions where a beacon cannot possibly be along just a single row. So for now, keep things simple by counting the positions where a beacon cannot possibly be along just a single row. So suppose you have an arrangement of beacons and sensors like in the example above, and just in the row where y is equal to 10, you'd like to count the number of positions a beacon cannot possibly exist. The coverage from all sensors near that row looks like this. In this example, in the row where y is 10, there are 26 positions where beacon cannot be present. Consult the report from the sensors you just deployed. In the row where y is equal to 20,000, how many positions cannot contain a beacon? Let's go here. And and I'll put this as an input into my first row. And I'll take this and put it into my example here. And then just say val are they numbered with 0 or so the position of val y test is equal to line lines dot first dot to int. And then for L in lines drop 1. Did we have a vector here? Yes, we had. Plus, minus. Not sure if we need the full vector, but this most probably not. Our from string. Where we can, well, we can change this from string here a bit to length 1, most probably will also not be needed. From string, and we said we would split that up by the comma, that's correct. But yeah, let's start here. So L dot split. Now we all know the closest beacons to each sensor. But how wide can we assume this grid is? Just the positions where there are no. Okay. Let's just split this by, I would say, add space. We can just split it by that. We can't do this with a regex as well, I think. I already used the regex in here. So with the regex, and we used it, where was it used? This is then sen. Just copy a line here. So I want this, this, this. Then we want to go here, say parts, want to say L, and then we would take sensor is vector 2D, and we would put in the parts 0, parts 1, part 2, part 3, beacon. And we could have sensor beacon pair, which gets sensor, which is a vector 2D beacon, which is a vector 2D. We have the fun Manhattan. Distance. We have B as a vector. This is just it's, I think, the components basically of both vectors. B. And then we would just say x minus b. This minus b. This, and then we would say this dot x plus this dot y math the absolute value of this and math to the absolute value of this, and we would then return this, and we put an int here. So we would now then want to know for one point. Can just parse them through here. Just create sensor beacon, and obviously we want to keep track of them. SB list is mutable list of sensor beacon pair. Add this, and then we would like to know that here we can also say so return. So, and we now have a line which we want to test. The thing is, how do we notice that? We can actually try to get all the dots from one this would be the Manhattan distance, and we actually know that this distance is sensor free. So can we kind of sample we can actually calculate the we know we are only interested in the y coordinate actually, so we can calculate if in this proximity there is, we can check if the sensor falls into the proximity of our line, I mean, we can also just render that grid, but those numbers are huge. So I think it makes more sense if we render the whole grid. This is insane. This is gonna be insane, yeah. So I would suggest that we not render the full grid, but we need to check for every pair. So for sensor beacon pair in the SB list, we know that on one line we can block the positions that are we only need to do the Y test. So I would suggest to say we want to check if we only actually need the beacon position to determine the radius of where. So we can actually call this fun clearance radius. And the clearance radius around the sensor of beacons is just a beacon would just be sensor Manhattan distance beacon return. We add the integer here. And we can now take the sensor, the Y coordinate, and calculate the distance with our Y coordinate, which is Y test. And we now want to know if this distance we want to subtract this distance from the sensor's speed, clearance distance, clearance radius. But this is basically because we can actually assume that if we have a sensor, we will have whatever is left in Manhattan distance, we would have that as a clearance. So if we then take we'll create a vector with our sensor's x value. Let me just think through that. With the x position, we have the y position. The y position is down. Then we want to keep our sensor's x position. And we take our y test in here. And we can actually already do that. This can take the y test position, and we can take our sensors. Yeah, and how many items I have left? I would then have a for loop that would while start would be minus math ups items. No, items left must needs to be this is allowed to be at minimum the minimum of this. I want to choose the maximum. The maximum, either this one or just if it's 0 items left, then I'm fine. If it's minus 1. And also, if items left is smaller equal 0, then I would say the start is math.ups items left, and the start greater equal 0, and the start is minus this, and the val end would be math items left. Well, it doesn't really make sense because items left can't be, so can't be negative here anyway, right? Exactly. And then we would have a for loop where we would just say I from in 0 till end, and in this time 0 dot dot end. Yeah, I want to have both included. And then I would say sensor plus I y test, and I would have a val set cleared on test line is just a set of vector 2D, and it's a mutable set. And in this case, I would just add and then I would say set cleared test online, and I would just return the size dot to size to string. So, not feeling overall confident. But let's give it a try. Mm-hmm. Mm-hmm. So regex.find, let's just check if this already throws the exception. It doesn't find it. The thing is, we have no we have, how does it look? let's just give it a try. If we have the minus set into here, just if the rest works. Obviously, we'll still need to figure that out then. Okay. Regex include negative numbers. Mm. Mm-hmm. Mm-hmm. Mm. Would I really need to put the dollar here? I don't really believe this. I think, isn't the dollar for terminating at the end? But we can give it a try. No, this doesn't work. Kotlin regex for negative numbers. Yeah, but regex match. I mean, Java would be the same. But I want to have this thing you could try. Then let's try this thing. I forget it. At some point I'll learn regex, not today. So we just take our line and split it at space x equals 0, x equals something. Then we know we can take val parts is equal to this. Then we know that then we will have the parts for the first thing. The first, we will then split parts at line 0. We will then split this with comma y equals, and this means we should now have val p parts 2, and we would also have a parts sensor, and this is parts beacon, and the beacon will be this one, and we would then have dot map. We'll split this by y, and we then would split Then we have the sensor, so we already know part sensor 0 and part beacon 0. To int, this will work. To int, and we can also already do this to int, and unfortunately here we still need to get rid of the comma, so we will take the sensor y would then be parts of 1.split, and we'll take the comma and we take the first part, and this would then be sensor y to int. So the part s would be yeah, that's actually true. We want the part 1 here, and if we split that here, we want the part 2 here. Parts looks like okay. Part s now is 2 comma y equals that. We'll split it by that, so we will be happy with it. This one is 15, that's nice, and the sensor y is but we want to have the parts of this one here. Ah, no, it should be the second. Oh, come on. Yes. And then I split it by y. Why do I get a size 1 out of there? Ah, there is a space in between. Okay. Let's just Yeah, this also needs to be parts B. Sensor Y is 18, and our line would be x 218 minus 215. Mm-hmm. Mm-hmm. Yeah. And 1 is 15. Mm-hmm. Mm-hmm. Mm. Can't I just set on an exception? Couldn't I do that before? Suspend. Well, if there is an exception somewhere. There is nothing really weird, right? Mm. No idea what this is now. Is this now up here? Yeah, okay. Sensor lists, 13 sensors. Or length, yes, this should work. 14 lines. Wait a moment. But we only have 13 sensors? Not puzzle 5, puzzle 15. Oh, we have 14, that's fine. Good. Then let's just check. So we have minus 1 item left. We have the sensor being sitting at 2 and 18. And our clearance radius for the sensor is 7. If we check that with the example input, minus 2 and 15. So it's 3 in this direction and it's 4 in the other one. So this sensor can't really will need 2 in this direction. But what line are we checking? Oh, we are checking line 10, so this is out of range. Yeah. So this is not, this does not influence us. Now we got some influence here. Oh, we didn't indent this. This is not very nice, but okay. This is anyhow a set, right? And we have the vector. Yeah. Come out of here. And this line basically can just yeah. The thing is, a census location is actually excluded if I get that right. So we can just do that, but then we would need to go to get our if there would be a beacon there, what would I do? There are 26% where a beacon cannot be present. Yeah, but still, I mean, if I take out the sensor, I get 27. So what does do they count here? That's actually the question. Notepad, open that up. And we have, how many hashes do we have in here? We got 27 matches. And I copied the wrong line. Got 26 matches. The thing is, the beacon itself doesn't count, which is a bit weird because there are 26 positions where a beacon cannot be present, and it's actually that beacon because... No, it's not, because they even... But I need to exclude it, right? Yeah, okay. That makes sense. So we'll get our... At this time, I'm not really... just do a flat map here, and I say set of it.sensor, it.beacon, to set and we can then just take the cleared removed known. We can just take this and do an evaluate of this expression, which will give us 26. This is very good. And then let's just rerun it. So, your handheld device indicates that the distress signal is coming from a beacon nearby. The distressed beacon is not detected by any sensor, but the distressed beacon must have X and Y coordinates, each no lower than 0 and no larger than big number. To isolate the distressed signal, you need to determine its tuning frequency, which can be found by multiplying its X coordinate by the maximum Y coordinate and then adding its Y coordinate. Yeah, okay. In the above example, the search space is smaller. Instead, the x and the y coordinates can each be at most 20. With this reduced search area, there is only a single position that could have a beacon. It's x14 and y equals 11. The tuning frequency of the distressed beacon is 6. Yeah, other big number. Find the only possible position of the distressed beacon. What is its tuning frequency? That means there is your handheld device indicates that the distress signal is coming from a beacon nearby. The distressed beacon is not detected by any sensor, yes, but the distressed beacon must have x and y coordinates, each no lower than 0 and no larger than 40, yeah, huge number. To isolate the distressed beacon signal, you need to determine its, that doesn't really matter. I mean, the tuning frequency is only, but that actually means I should, within this area, there can only be one position where the sensor could be. Does that mean it? So I need to this 4 million or but I need to multiply them together in that way. Yeah, with this basis, this actually means that it's multiplied by 45. No lower than 0 and no larger than, this is 4 million by 4 million area. The question is how to filter this efficiently. Because obviously when we can go with this line approach and we just count everything that's within that area and then we'll I mean, it looks like everything else is anyhow covered. 4 million by 4 million, that would be, that's huge. That's really huge. And even if we do it line-wise, that's quite a thing. It seems like there should be a smarter way to do this than by just trying out all, just testing this out. Well, we can basically exclude those whole areas. So maybe it makes sense to determine the corners of the square and that we exclude. How can we then efficiently test this? I mean, of course, we can test this against all squares, but we would need to test this 4 million times 4 million times. Because we don't have so many beacons actually. We could do this with kind of square intersections. So we know that this area is blocked, and we'll subtract this area from this with this alignment of well, we know how they are aligned, kinda. They are always aligned like this. They're always in the 45-degree angle. There's actually not really another option, right? Could also be somewhere smaller inside. But actually, there are not a lot of things there we need to test, but yeah, can't really think of anything but how large are those? They're around the 3 million. I mean, over this we can check each line, and we can check if any of those lines would come close to that size, but it would be, I guess, more efficient if we could at least for each line outrule what is if I would just check for each point in each line. This is heavy, but I could do this calculation, but maybe I could also outline, like I know how those beacon fields are placed, so the only interesting thing is if they step back or if they step up. But the other thing is, like, if I see it equation wise, there's only one point, which is, there should only be one point which is outside of all this area. And if it's only one point, then it actually, if it's in this grid, this is a unique point. We actually know that it can only be on the outer hull of one of those beacons. There is actually no real other possibility. Because if one beacon would just be moved by one, our outer hull, it must be on the outer hull of those. Not of all, maybe, but at least of one. And possibly to have it limited to one, I think we need to have it on 4 hulls. So there needs to be one point in the grid where 4, I would just say it should be at least 4. If I think you could otherwise always find a different point if it's not 4. So I think we need to have actually 4 beacons being close to it. So like, let's say if we increase the Manhattan distance of 4 beacons by 1, on this kind of border it needs to sit. So the question is, can we calculate that? We would just need we would have our radius, and we could actually calculate, we know the x distance, we know the y distance of these sensors, and we know their radius, and we can basically triangulate it. So it's something I want to try out. I think we have this SB list here. I think we can remove this for now and remove this for now. And I would would move this method to here. No, not part 1, but this one. Parse sensor beacon list. Call this part 2 here. And I would, we'll don't need the first line, but we'll need to skip it. but it anyhow skipped in there, right? Yes. So fine with that. And I would now say we can take the list and if we have the Manhattan distances and we'll just need to look at, I think we can do it with two. I think that should be two of the circles can have at maximum, can they? Well, they can have more points intersecting, right? Yes, through the grid layout they can, but on a border layout, if they would, I only want those who not do no. I can't outrule the others, but I'm not interested in those points. So I'll take the list and just sample the points where at least two borders overlap. Yeah, but it could also be that it's just one and it's in the corner of those. Yes, it could. It could indeed be that way. But if it's in the corner, well, I could just ignore that fact and afterwards pick the one that's still inside. Yeah, but if I don't do this, I might have troubles. Yeah, not sure. No, I think that will work. Only thing I need to make sure to check. I just check all pairs for now. So for SB1 in SB list, and then I just also get the for SB2 in SB list, and I would then just record a set value set possible, which would then just be a mutable set of, and we want our vector in there. And we would now just say if sb.1 is equal to sb.2, I would just like to, there is a reference equals. If this is not the case, then I want to calculate where they calculate the points where their radius overlap, and I think if I'll take sb.1.sensor, sb.2.sensor, I get the distance between those 2 points, but I would actually like to know the point on their outer hull, so I can take this and it needs to be, and this is anyhow the minimum. I would be able to subtract that from SB1 dot I think I would need them. Do I need the Manhattan? I'll just take the Manhattan distance for now. SB2.sensor. So this is the distance they have, and I would now want to. This is gonna be, yeah, and I want to find out where the points are Hmm. Where both of them, they can either have this distance and they can have it one or two times. If this distance here is mm, the outer border would be SB1 dot clearance radius plus 1 R1 and R2 would be that. If R1 plus R2 would be larger than is smaller than the sensor's Manhattan distance, only if this is larger or equal. I think both this, well, if they meet exactly, this can be the case, then we would have this then can be a set of points, right? Yeah, but the difference is actually I just take the Manhattan distance, I subtract this, and then if I take the Manhattan distance between both, subtract their Manhattan radiuses from it, and then I know I have an overlap area. This is about their size. No, it doesn't really matter about this size, because if I get it with the Manhattan distance, I get those two rectangular shapes aligning, then all the border is mine. But yeah, yeah, leave it for now. Bit unsure with my current solution. Maybe I'll definitely put it on GitHub, but I'm not really getting ahead now. So thanks for joining in. Have a nice day.